Today we are going to be investigating Earth's structure. Please take out your green Earth Science Review packet and turn to page 2. You'll see on the top it says Earth structure. You'll also see an image similar to this. Can you identify which layer is the crust, mantle, inner core, and outer core? If you said that the crust was this thin layer on the outside of the Earth, you'd be correct. If you said that the mantle was directly under the crust, that is correct also. Next we have the outer core and the inner core. Now, this is all well and good. However, I think we need a little bit more information about these 4 layers than just the terms themselves. In your note-taking packet, I want you to write down all the pieces of information I'm going to give you about each of the layers of the Earth. Let's first start with the crust. The crust is really like the Earth's skin, right? It's this outer layer, it's very thin, and it's the crust where we have both continental crust and oceanic crust. Underneath the crust, we have our mantle. Now remember, the mantle is a semi-solid rock, and it has undergone immense amounts of heat and pressure. Because of this, changes in heat, we have what's called convection cells. And really what's going on here is we have heat rising, cooling at the surface close to the crust. Once it cools, it falls back down again because it becomes more dense, becomes heated, rises back up, and what this really creates is called convection cells. It's this circular motion of heat. And it's this motion of heat that actually drives all of our plate tectonics, which we'll be talking about later. Underneath our mantle is our outer core. Our outer core is made out of a nickel-iron alloy. It is liquid, and it is immensely hot here. It's between 3,000 and 5,000 degrees Celsius. It's actually the moving of this liquid that creates our Earth's magnetic field. The inner core is now solid due to an immense amount of pressure, and it is around 500 to 9,000 degrees Celsius, and this too is generating our magnetic field. The fact that the inner core is solid and the outer core is liquid, and the fact that they both generate a magnetic field comes into play later when we talk about Earth as a magnet. Please make sure that you write down information about each of these layers of our Earth. Let's look at Earth as a magnet. The Earth is like one massive magnet. Our entire Earth is a magnet due to our core. The liquid outer core controls the Earth's magnetic field. As the liquid outer core moves, it actually changes the direction of our magnetic field, the north-south orientation. Look at the image below. Do you notice something kind of quirky about it? Do you see how the magnetic south pole is actually pointing in the direction of our geographic north pole? Do you also see that the magnetic north pole is actually pointing towards our geographic south pole? This is kind of a crazy idea, and we'll talk about how this happens and why don't our geographic and magnetic north and south poles line up appropriately at this time. I'd like you to take a moment, and in your note-taking packet, I actually want you to draw these. Do you see these lines? These are actually called magnetic field lines. Magnetic field lines show us how far a magnetic force can be felt away from an object, and then how close together the field lines are actually tell you about the strength of that magnet. Please, in your image in your note-taking packet, draw the Earth's magnetic field lines. Also, please label the geographic and magnetic north and south poles. Make sure you appropriately line them up. Let's talk about what the Earth actually does as a magnet. Because our Earth is a massive magnet, we have this huge magnetic field, which is the region around the Earth where the magnetic force can be felt. This is very beneficial to us. Do you remember when we were in astronomy and we talked about the sun's solar flares? And we talked about how the sun does things like coronal mass ejections, where it hurls electrically charged particles throughout our solar system. This also occurs with solar winds. And we talked about how the reason that the Earth is not greatly affected by these is due to our magnetic field. We also learned about how there is a gap in our magnetic field at both the top and the bottom, and in there we can have energy siphoned through. And when that happens, it creates our auroras. Go ahead and write what forms the auroras on your note-taking packet. Auroras are formed due to charged particles from the sun hitting the oxygen and the nitrogen atoms in our air. And when these atoms become excited, they actually give off light. And this light can be a form of many colors. Let's look at this here. This video right here is actually showing you some auroras in both the South and North Poles. This video is coming from the North Pole. Now I would like you to actually turn your sheet over. When you turn the page, you will see that there is a region that says plate tectonics. Let's take a moment to talk about plate tectonics. So we know that the Earth has a crust and a mantle, and we know that the mantle is fluid and moving with convection cells, and that those convection cells actually drive what's called plate tectonics. The Earth has two different types of plates. Can you determine or guess which type of plate is under each of these boxes? We have one that is very thick but less dense, and we have one that is thin and more dense. If you said that the continental crust would be the thicker one, you'd be correct. The continental crust, the crust that we live on, is thick and less dense. It is made of granite. Then, under that, we have the oceanic crust. The oceanic crust is thin and more dense, and it is made of basalt. These two crusts are the two things that we deal with when we start talking about plate tectonics. Let's talk about this. What direction do plates move? They can really move in three different directions. One could be a convergent plate boundary. Look at the arrows here. I want you to both draw and define a convergent plate boundary. So in your note-taking packet, I would like you to draw both of these arrows and define convergent plate boundaries. When you think of a converging plate boundary, if you converge with another object, you collide with it, you come together and you make contact. And this is called a convergent plate boundary. With convergent plate boundaries, when these things happen, when you have an oceanic and oceanic crust colliding, you can have things like volcanoes form. And those volcanoes can become so large that they actually create islands. Also, you can have an oceanic and continental plate colliding. And when this happens, because the oceanic plate is more dense than the continental plate, it'll actually slide underneath it. When it does this, it experiences a lot of heat and pressure right here. And when that happens, that actually makes the crust melt and you have magma formed. That magma will rise up to the surface and it will actually end up creating a volcano. When we talk about the ring of fire in a little bit, what's happening here is we have a lot of oceanic crust going underneath continental, and this creates volcanoes. The last form you can have is a continental and continental crusts meeting each other, and when this happens, we have mountains that are formed. What if they don't come together? What if the two continental plates are actually moving in opposite directions? So here, I want you to draw and define. You should have two arrows going in opposite directions. This is a divergent plate boundary. And when you think of divergent, think of things drifting apart, dividing. This is divergent. When you have a divergent plate boundary, this is also called seafloor spreading. The seafloor is actually spreading apart on both sides of the mid-oceanic ridge. And when it spreads apart, you actually have new crust that is being formed in the middle of this mid-oceanic ridge. And the last type of movement our plates can have is this. Please draw the arrows and define transvergent plate boundary. Do you see how the two arrows are going in opposite directions? This is when you have two plates that are actually sliding past one another. When this happens, a couple things can form. The biggest thing that we call this, the sliding of plates moving in two opposite directions, is faults. Here we can see that we have faults that can create folded mountains, or what's called fault block mountains. It's when one plate moves up and the other one slides down. So let's do a quick review. Do you remember this from 6th grade? The hand motions to show both convergent plate boundaries, having your two fingers point towards each other, divergent, having your two fingers point away from each other, and transvergent, having your two fingers pointing in opposite directions. Remember this when it comes time to test. Let's see, can you match up the arrows to the appropriate definition or term for a plate boundary? When two arrows are moving apart from each other, what kind of plate boundary do we have? If you said divergent, you would be correct. When two arrows are sliding past one another, what kind of plate boundary do we have here? If you said transvergent, you would be correct. And if we have two arrows that are pointing towards each other, what kind of plate boundary do we have? If you said convergent, that is correct. Let's talk about this convergent, the idea of two plates coming together, or transvergent, two plates sliding past each other. When this happens, we can have earthquakes. I want you on your note-taking sheet to define earthquakes now. Earthquakes are a shaking or trembling that result from movement in the rock. Why does this happen? It's due to movement of our plates. So let's look here. You can see here that when the Earth is actually moving, the Earth's lithosphere, which is that rigid crust in the upper mantle, is broken into separate pieces. And when these plates collide, there can be a buildup of stress. Or when these plates slide past each other, there can be a buildup of energy in the rock. Eventually that energy will break and the rocks will slide past one another. And when they do this, this actually produces an earthquake. Let's look at this earthquake. The area in which the Earth actually moved is called the focus. And this is where all the energy waves are then sent outwards. Remember when we learned about seismic waves? We were talking about waves in light earlier. Here is the focus. This is the source region. This is where the movement began, and then the waves ripple outward. The direction right above the focus on the land where we live is called the epicenter. So let's just look at these in a little bit more detail. You can see here that we have a focus. The focus is the area beneath the Earth's surface where the rock that is under stress breaks, triggering an earthquake. And then you can see that the epicenter is the point on the surface directly above the focus. Let's look at something else that can happen due to plate tectonics, and that is volcanoes. Please define volcanoes in your note-taking packet. A volcano is a mountain that forms in the Earth's crust when molten material or magma actually reaches the surface. So remember, when we have two convergent plate boundaries, we can have the melting of rock occur underneath. When that rock rises up to the surface, this is what's called a volcano. We can have three different types of volcanoes, which you learned about in 6th grade. There's cinder, shield, and composite. Remember when I was telling you about how we have all of these convergent plate boundaries occurring where you have oceanic rock that is going underneath continental? We call this the ring of fire. Right here you can see we have all of these oceanic plates subducting underneath continental plates, and this creates volcanoes. Let's take a moment to review everything that we have learned thus far. When we talk about the Earth's tectonic plates, we can actually name them. You can see here are some of the names that we have for the major tectonic plates here on Earth. Tomorrow in class, we will continue to review the different types of plate tectonics. We will look at the effects of these plate tectonics with things like volcanoes and earthquakes, and we will be building blocks activity to review all concepts covered today, including the Earth's layers.